In this video, we are going to be talking about zeros of a polynomial function. These are also called the roots of a polynomial. For a polynomial function f, we say that a number r is a zero or a root of that function if f of r is equal to 0. So essentially, zeros or roots are the inputs that you can plug into the function so that you get 0 as the output. Let's take a look at some examples. Here we're looking at the function defined by f of x equals x squared minus 5x plus 6. We're asked to check that 2 and 3 are zeros or roots of our function f. To confirm that these numbers are zeros of our function, all we have to do is plug them into our function and see if the output is equal to 0. So for example, if we evaluate f of 2, we have 2 squared minus 5 times 2 plus 6. This is going to give us 4 minus 10 plus 6, which equals 0. So since the output here is equal to 0, we say that 2 is a 0 or a root of our function. Now let's check that 3 is a 0 or a root of our function. Let's evaluate f of 3. That's going to give me 3 squared minus 5 times 3 plus 6, which is 9 minus 15 plus 6, and again, that's equal to 0. So we see that 3 is also a 0 or a root of our function. Let's look at another example. In this example, we're given the graph of a polynomial function g. We're asked to find the zeros of g. Again, the zeros of a polynomial function are the inputs that you can plug in so that you get 0 as the output. When we think about graphs of functions, the inputs correspond to the x values, the outputs correspond to the y values. So our question here is the same as asking, if we look at the points on our graph, for which x values are the corresponding y values equal to 0? Looking at our graph, we see that when x is negative 4, the corresponding y value is 0. When x is negative 2, the corresponding y value is 0. When x is 1, 3, and 5, the corresponding y values are all zeros. So we say that the zeros or the roots of our function g are the numbers negative 4, negative 2, 1, 3, and 5. You see from this example that the zeros of a function are essentially the same as the x-intercepts. One important thing that we'll need to know related to the zeros of a polynomial function is something called the factor theorem. The factor theorem tells us that for a polynomial function f, a number r is a zero of f if and only if x minus r is a factor of f of x. Let's go back to our first example to see if this factor theorem makes sense. If we look at our function f of x equals x squared minus 5x plus 6, let's try to factor that polynomial. To factor x squared minus 5x plus 6, we need two numbers that multiply the 6 and add up to negative 5. Those two numbers would be negative 2 and negative 3. So the way our function here factors would be x minus 2 times x minus 3. In our example, we saw that 2 was one of our zeros, and indeed, we have a factor of x minus 2 in our polynomial function. 3 is another one of our zeros, and we see that in our polynomial function, we have a factor of x minus 3. So it seems like our factor theorem holds true. If I have any number as a zero, we see that x minus that number is a factor of our polynomial. Let's see why this might be useful for us. In our second example, we're given the graph of the polynomial function g, but we're not given the formula for g of x. Knowing the zeros of g will give us an idea of what g of x looks like. For example, we see that 1 is one of the zeros of g, which tells us that x minus 1 is one of the factors of g of x. Similarly, 3 is one of the zeros of g, which means that x minus 3 is a factor of g of x. And if we go over here to negative 4, we see that negative 4 is one of the zeros of g, which means that x minus negative 4 is one of the factors of g of x. Knowing that our polynomial function g has all of these factors, we can say that g of x is a product of x minus -4, which we can write as x plus 4, times x minus -2, which we can write as x plus 2, times x minus 1, times x minus 3, times x minus 5. Again, we have these factors of g because -4, -2, 1, 3, and 5 are the zeros of g. Now, this isn't necessarily the entire formula for g of x. We just know that g of x has these factors, but it might have some other factors as well. So in this video, we learned about what a zero of a function is, and we learned about the factor theorem, which tells us that if a certain number is a zero of a polynomial, then x minus that number is a factor of the polynomial. In our next video, we'll look at an example of finding the formula for a polynomial function using its zeros.